Welcome to our training on Modbus IoT data acquisition systems. Today we will start with a brief introduction, then introduce IoT, Internet of Things, a network of things that are embedded with sensors and technology enabling the connection, communication, and exchanging of data with devices over the internet. We will go over Modbus data acquisition systems. Modbus is a serial communication protocol commonly used for transmitting signals from instrumentation and control devices back to a main controller or computer. Modbus RTU communicates over serial networks, and Modbus TCP communicates over Ethernet networks. We will be discussing remote monitoring systems that allow for the viewing of the status and conditions of industrial machinery and other equipment from another location. Alerting and reporting capabilities help keep systems safe and stable. Modbus leak detection systems prevent costly water damage, have audible alarms, and trigger relay outputs to shut equipment off to prevent further damage. We will discuss how utilizing IoT and Modbus technology for real-time data acquisition and communication. At the end of the training, you'll see a live demonstration of Modbus IoT data acquisition with SCADA software. If you have any questions, please enter them into the chat box and we will address them at the end of the training. ICP DAS USA was established in 2001 and provides industrial control products and data acquisition system solutions that are low DC voltage and operate in extreme temperatures from -13 degrees Fahrenheit to 167 degrees Fahrenheit, or -25 Celsius to 75 Celsius. I'm Maria Santella, our sales manager. I've been with ICP DAS USA for about 12 years and was previously an application engineer. Robert Murao, our senior technical application engineer with extensive experience in testing, troubleshooting, and solving complex problems and implementing applications, will be giving a live demonstration later in the training. Our headquarters is located in Houston, Texas, and we manufacture products in Taiwan. We ship out-of-stock items within 7 to 10 days and in-stock items within 1 business day. We provide free technical support and a 1-year warranty. We focus on providing the best customer experience and innovative automation technology. We appreciate customer feedback to best serve you and to improve our customer experience. Machines have used wired communication to exchange information since the early 20th century. Machine-to-machine communication has evolved into wireless telemetry and internet-based applications. Internet of Things, IoT, refers to a network of physical hardware devices that have sensors for data collection. They are networked over the internet and shared over the cloud. They are integrated with software. IoT enables the collection and analysis of vast amounts of data that helps with optimizing processes, reducing costs, enhancing efficiency, and more. IoT is connecting factories, improving supply chains, streamlining networks. This is all happening in many different industries. In manufacturing applications, IoT technology is helping track production cycles, helping with analysis and optimization of production flow, and with managing inventory. Sensors and equipment are installed to track signals and different steps in the manufacturing process. Scales under conveyor belts are often used to sense the weight of manufactured products. The weight's collected and sent over the network to a computer that logs the information. The sensors and data acquisition equipment are on the front end of the application, and the SCADA or other software is on the back end of the application. In transportation systems, IoT is optimizing routes, tracking automobiles, monitoring weather, and tracking distance. In utility systems, IoT is helping with energy monitoring and improving efficiency of the grid. IoT and traffic monitoring systems, real-time traffic analysis data improves congestion and helps keep the roads safe. In agriculture systems, IoT is helping with farming automation, keeping crops optimal, and improving the food supply. Modbus is a communication protocol for transmitting data between devices over serial lines or Ethernet cabling. It's a master-slave protocol where a master device controls the transactions with slave devices that respond to requests to read or write data. Modbus is often used to connect PLCs or PCs running SCADA software to I/O and instrumentation equipment for automation, monitoring, and control applications. Data is exchanged through 16-bit registers. It's up to the master, which is the controller or PC, to request and use the data. Our WinPack and touchpad controllers are often used as Modbus masters. Our Modbus RTU I/O modules and rack-based data acquisition systems are Modbus slaves. Modbus RTU is transmitted over serial lines like RS-232 or RS-485. Modbus TCP communicates over Ethernet cabling. Data acquisition is the process of sampling physical information and the conversion of the collected information into digital values for programs to use. Data acquisition information is used for implementing control logic operations based on conditions like the turning on of a fan based on the temperature, the turning on of a pump based on tank level, and the opening of valves based on pressure levels. In this picture here, you can see our ET7026 Modbus TCP-based data acquisition module has sensors connected to it, and data is collected and put into registers. A computer running SCADA software is connected over Ethernet and collects the measurement data from ET7026. That's a Modbus TCP-based data acquisition module with analog and digital inputs and outputs. The TPD433 Modbus TCP-based touchscreen controller is also connected to the system over Ethernet cabling and displays data from the system. We provide a comprehensive selection of Modbus RTU and Modbus TCP-based analog and digital data acquisition modules. Our analog input selection comes in current, voltage, RTD, strain gauge, thermistor, and thermocouple inputs. We offer voltage and current output modules with up to 8 outputs, 8 analog outputs. We provide power meters that calculate and provide energy information, including kilowatts, kilowatt hours, power factor, and reactive power. Our digital selection includes AC, DC, counter, encoder, and relay modules. We also provide combination modules that have analog and digital I/O on board. Modbus RTU equipment communicates up to 4,000 feet, which can be extended with our I-7510 RS-485 repeater. Modbus TCP equipment communicates up to 326 feet, which can be extended with Ethernet switches like our NS205. Our Modbus data acquisition modules have dual watchdogs, so the hardware watchdog resets the microprocessor if there's ever any issue with reliability or for reliability. The software watchdog monitors communication and will trigger the output to go to a safe value state if the host communication fails, ensuring higher reliability. Many of our analog input modules offer high overvoltage protection for the analog input channels, which improves reliability and makes the system more robust. Our thermocouple RTD and thermistor modules offer open wire detection that help with system safety. In many applications, it's dangerous when systems cannot remotely monitor the open wire sensor status. When sensor wires are broken, the controller won't know what the temperature levels are, which often causes the system to overheat, resulting in fire or explosions. Our thermocouple RTD and thermistor sensors help keep systems safe. Wireless Modbus data acquisition equipment helps with getting information where wiring is inconvenient. ZigBee is a self-organizing mesh network that supports different topologies, including star, cluster, and tree. ZigBee networks have one ZT2550 or ZT2570 host coordinator that coordinates the communication path in the network. Both our host coordinator converters have an RS-232, RS-45 port for serial communication. The ZT2570 has an Ethernet communication option. Our ZigBee slave converters, ZT2551 and ZT2571 are connected to Modbus RTU devices over RS-232 or RS-485 bus. And the ZT2571 has an Ethernet port for connecting to the Ethernet network. ZigBee supports communication distances up to 2,296 feet or 700 meters line of sight. Each ZigBee end device acts as a repeater, and we also offer repeaters for extending communication distance. The WF2000 modules communicate over Modbus TCP, and they communicate over Wi-Fi, which supports communication distances up to 164 feet or 50 meters, and that can be extended with Wi-Fi access points. We provide free e-logger software for control and monitoring systems. It's used to easily set up control and monitoring systems on Windows computers or Windows WinCE 7 embedded systems. It allows you to make data logs in a CSV format. You can make graphical user interfaces with drag and drop buttons, gauges, sliders, numerical displays, and more. You can make up to 32 HMI pages. You can display trend graphs on them where you can see your measurement values and also the on-off statuses. eLogger supports Modbus TCP server, so you can read and write data with Modbus TCP protocol. You can publish eLogger to a web server, so it's web page accessible for remote monitoring and control. It runs on Windows, WinCE 7, and Windows Embedded Standard 7 systems. You can use it in the background, so if no HMI is needed, you can still use eLogger to, for example, to make the data logs. You can set up different users with different levels of access. So some users, they can have full access and open projects. Other ones, they can start and stop projects, set analog and digital output values, and then you can also have other users that just switch pages for monitoring. eLogger supports ISAPI for more advanced applications, so it also allows you to design web pages with JavaScript, and you could easily build Android apps with MIT Inventor. Modbus IoT data acquisition systems typically consist of hardware and software components, including sensors attached to Modbus communicable data acquisition modules, which are connected to networks through serial to Ethernet gateways, Ethernet switches, and our wireless equipment. IoT equipment like our WISE 5231 connects to Modbus data acquisition equipment and can be configured to implement control logic and pass the data back to SCADA control and data acquisition systems. The data can go to cloud systems or directly back to a SCADA system. Remote monitoring systems include data acquisition hardware connected to sensors at the physical location of what you want to measure. Data loggers are often used to log data locally, and IP cameras are often included in remote monitoring systems, so you can visually see the status of the system. Controllers equipped with the program implementing remote logic control operations are often involved. Serial to Ethernet converters, gateways, Ethernet switches, and wireless equipment are often used to get the communication back from remote locations. SCADA software allows for viewing the status from another location, and all those kind of systems that I just mentioned, we provide all that equipment, even in the IP cameras. Engineers in production management can monitor machines and manufacturing systems in different locations from a web browser. They can track production process, control equipment, and view reports for analysis. With remote monitoring systems, you can visually see the status of systems, facilities, and equipment in distant locations like other counties or states. SCADA software allows you to visually see the status of remote equipment on screens Bar graphs indicate the level in the storage tanks. Now, this is a bit more advanced than the e-logger software I just showed a little bit ago. And here on the screen, you can see the water level is shown in numeric text below the tanks and shows in green when the levels are in the desired range, shows in yellow when the levels are in an acceptable range, shows in orange when the levels are less than 25%, and it shows in red when it's below 10%, which is bad for the system. There are buttons that you can click to remotely close the valves and turn off pumps. Trend graphs show the status of tank levels over time. Customized reports are getting emailed out at scheduled times. The alarm window at the bottom shows when levels are out of range and also shows high pressure warnings. Animated graphics show a realistic visualization of the system status. Indusoft SCADA software is publishable to a web server for remote access through a web page. Dedicated viewer stations display system status. Local HMIs allow for interaction with I/O equipment. Indusoft runs on Windows or Windows embedded operating systems. Licenses come in development, runtime, and development and runtime in one. You can get soft key licenses by email that you can just key into your system, and then also USB hard key licenses if you want to get the hard key. The software is user-friendly and easy to use. It has an intuitive interface. It has advanced analytics capabilities for easy identification of patterns and trends in data for detecting anomalies and potential issues. This helps with industrial organizations to make data-driven decisions and optimize operations. Our WISE 5231 Modbus IIoT controllers have logic rule engines, can trigger outputs based on inputs, support scheduling operations, have account management. They integrate with IP cameras. They send text messages, log data, and they have a web browser for remote monitoring and control. They support math operations and communicate over Modbus for easy integration with other systems. They're configurable over a web page, and this is a wireless, the WISE 5231 4G. That is a wireless IIoT controller. These connect with devices over or machines over the internet for remote monitoring and control, and allow for the easy integration of sensors, controllers, and other devices into an IoT network, enabling collection, analysis, and utilization of data from different sources. WISE 5231 supports Modbus RTU, Modbus TCP, SNMP, Wi-Fi, and MQTT. And then it has the built-in web server, so you can remotely access it for easy configuration and management of your system. Through IoT and integration of Modbus-enabled devices, remote monitoring and control of industrial processes is possible from anywhere in the world. Our ISN series IoT-enabled data acquisition modules are reliable and flexible modules designed to enable remote monitoring of temperature, humidity, liquid, and light through the internet. In Modbus leak detection systems, IoT-enabled ISN 101 Modbus RTU liquid leak detection module is connected to a CALLD DC100 L100 10-meter long liquid leak detection cable. The information is passed to the WISE IoT concentrators that have a logic rule engine for implementing control logic through if, then, else if type rule conditions that are configurable through a web page. ISN 101 has an audible alarm and a relay output that gets triggered if liquid is detected. So the water valves and the systems are shut off, and personnel is notified immediately through text messages, preventing further issues. The WISE 5231 M4GE, along with ISN 201E and TPD 433, automatically control electric curtains based on a schedule and based on light, humidity, and temperature levels, keeping the room at the desired temperature, which saves on heating and air conditioning costs. The TPD 433 Modbus-based touchscreen controller allows for manual control of the curtain. The WISE 5231 M4GE has cellular communication in that way you can use it in remote systems that don't have internet access. It performs all the control logic rules and scheduling. It also sends out system alerts. When Modbus PIR sensors detect motion in an office room, lights, HVAC systems, they get turned on and an alert is sent to a designated smartphone. The PIR sensor detects motion in a defined space, and then it sends data to WISE 5231. The WISE 5231 communicates with other devices and systems in the IoT ecosystem and triggers actions based on the detected motion. Our passive infrared 360-degree motion and temperature sensor modules can be powered with AC voltage, low DC voltage, or powered over Ethernet. They detect motion and presence for lighting, HVAC, and other monitoring and automation applications. Our G-4510 M2M machine-to-machine C-language programmable controllers are being used in Modbus IoT data acquisition and remote monitoring systems. They communicate over the cellular network and can send and receive text messages and communicate with other control systems. Them being C-language programmable, they're very flexible and they can be used for all sorts of different kind of applications. They have I/O on board for automation and monitoring, and they're low DC powered, and they're often powered by solar panels in remote locations. We do provide a wide variety of demo programs that help with development. IoT plays a crucial role in enabling the collection and transmission of Modbus data from remote locations to a central monitoring system. IoT-enabled Modbus data acquisition systems enable remote monitoring and control of a wide variety of equipment and processes, allowing for easy identification of issues and operations optimizations. IoT-enabled data acquisition systems offer real-time data monitoring, which means that businesses can quickly identify issues as soon as they arise and respond quickly to prevent downtime or other negative impacts. IoT also enables data collection from remote locations, making it easier to manage equipment in hard-to-reach areas. IoT data acquisition systems are highly scalable and can be expanded easily as a business or system grows over time. Now I'm going to pass it over to Robert Murao, our Senior Application Engineer, who's going to be giving a demonstration with SCADA software.
Let's see, let me share my screen. Let's see. Okay, what I'm going to do first is show you the main demo for AVEVA Edge. About a year and a half ago, AVEVA Edge, InduSoft was rebranded as AVEVA Edge, upgraded to AVEVA Edge. So if you have InduSoft existing runtime licenses, you need to stay with InduSoft and to maintain those runtime licenses. For newer applications or for upgrading to the latest product, you'd want to choose AVEVA Edge, and AVEVA Edge 2020 is the current version. I think there's 2022, or I'm sorry, 2022 is coming out very shortly.
We do sell upgrades from InduSoft older versions, for example, like 6.0, 7.0 to InduSoft version 20, or you can go from an older version of InduSoft, for example, and upgrade that to AVEVA Edge. So the softwares are kind of, they are one and the same, or you can just buy AVEVA Edge and go from there, but they are kind of like the same software, just the InduSoft is the older versions.
Yeah, InduSoft is the older version of AVEVA Edge. Let me just go back here. I need to like this. Let me start the project. Wonder why the screen's not showing up over here. Well, let me just show you what I have earlier. Let's see, for InduSoft or AVEVA Edge, it's a tag-based SCADA system. So you need to create different, use the different widgets and objects to create and visualize your application. So for instance, on this screen, this is an animation screen. I'll show you this running in a few minutes, but essentially what you do is you use the either images inside InduSoft or AVEVA, and you modify the tag associated with the device to either move, change color, numerically show a value, visually show transparency, rotation, and size changes. Let me show you this. There we go. Okay, so I now have the sidebar, which is my controls. Not sure why it had that little hiccup before, but I was trying to make some modifications for this project. So I may have done something and just didn't know I did something or saved something weird. But let's see. Okay, so I'm going to go back to the main features. This is the screen I was showing you earlier. This is what I like to show customers when they first have a project they need to create. It'll give them some ideas of objects and animations which can be used in their project. If you want to use something similar, use the same exact object, you can simply cut and paste these from the Indusoft or AVEVA Edge demo and use it in your project and just modify the tags associated with the values. The bar graphs in the top left simply have a static object, and there's a bar graph which moves left to right or up and down. The color changes are pretty straightforward. It's like when say for a digital tag, the value's off, you want it to be red. For the value to be on, you associate that with green. So when the tag value changes, the color will change as well. The numeric and data entry fields, those are used for, say, for instance, if you want to set an analog input value, or I'm sorry, analog output value, so that something that's going from 4 to 20 milliamps in the background is controlled by 0 to 100%. So you can do scaling within AVEVA Edge or Indusoft. You can show position transparency. I don't use that often. The size of the object, I do use that quite a bit. Essentially, you just associate the analog value with a 0 to 100% tag or scaled value, and the image just grows or shrinks based on the value of that analog tag. The trend curves, these are also heavily used both in our AVEVA Edge, Indusoft, as well as our Easy Data Logger and eLogger softwares. These numerically or visually show the status of, say, tank levels, flow, production, number of boxes, number of packages, overall equipment efficiency, and so on and so forth. You just create a trend curve and associate those with the numeric scale on the left side with what scale that you want to do. Say, for instance, if you're displaying the tank level from 0 to 100%, the level will go from 0 to 100%. You just associate that with single line. In this one, it incorporates many different values, but you can certainly do one or many, and you can have, say, 5 different tanks with different lines on the same graph as well. The alarm window is also very good. So for instance, if your tank level is going to overflow, you can trigger an alarm. It'll pop up a screen similar to this, and you could acknowledge it, or you can what do you call it, fix the problem, and then the alarm will disappear. If the alarm doesn't disappear, then you need to send someone there really quickly to fix the problem. Let me show you some industry examples. Indusoft / AVEVA Edge have some wonderful industry examples which show the different processes happening. This one right here is the machinery demo. It just shows a press, or I guess a conveyor belt with material going through. Presses happening, stage 1, stage 2, stage 3. This is probably bending and forming. Then it does another manipulation of bending and forming, and a third stage as well to a different press. Parts. Oh, okay, this is for fenders. So I guess for like Toyota or vehicle fenders. Then the other one I like to show are the simpler ones. This is just an oven furnace demo. It shows a warning symbol if the temperature goes too high. There's buttons to control the different furnaces. It's just a very simple animation. This one right here is the size demo. Up here, you can see the animation. It visually goes from 0 to 100%, or just changes based on a tag value. But if you look at this picture, there's really not too much to it. It's a nice background image with some animation up here, some buttons, and a bar graph or slider over here. And you also have some manual control buttons, which are used from the InduSoft or AVEVA Edge library. And then let's see the water demo. This one just has a nice background image, a trend curve on the left side showing the process happening, some color changes, so it's showing animation, and some text fields showing the actual value of the tank. And at the bottom, an alarm window or history window to show various levels or messages. Okay, the wastewater demo. Again, some text windows up here showing values changing, some control buttons down here, a nice image here showing the process, and we can turn it on. I thought we could, but I guess we can't. This one we can, I think. It's not working right now, but I probably changed something. That's probably my fault. But there's other demos here for different industries. This one's oil and gas industry, just showing. Let me minimize that. I have this little pop-up that pops up all the time. It blocks my view. So you can see the PSI in gallons per minute flow for the oil flow and pressure. And it's got some animation up here. And you can see a trend curve over here. Wind power, solar industry, or solar plant. Okay, here's an equipment panel, or instrumentation panel rather. Just some nice gauges over here. Again, from the InduSoft library, or the library in AVEVA Edge as well. Let's see. The next thing I want to show you is just some overall information on how to bring data values in to the software. So let me get a little slideshow I have over here with some images. Slideshow start. Okay, so for this demo or setup, I'm using our M7026 Modbus RTU slave device. It has these types of channels: 6 analog inputs, 2 analog outputs, 3 digital inputs, and 3 digital outputs. If I wanted to incorporate those into InduSoft or AVEVA Edge, I just simply create the tags and connections. I'll show you that in a few minutes, based on the configuration. So this configuration, the Modbus address is set up as 1. For Modbus RTU, each individual device must have its own address. So you can have address 1 for this, then address 2, address 3, all the way up to 255 for this Modbus RTU bus. If you want to add multiple buses or COM ports, for instance, you can add more slaves, or if you have Modbus TCP, they're more versatile and you can have a lot more slave devices and faster communication. I actually prefer Modbus TCP because you can also use the existing Ethernet infrastructure of a building. You can use standard switches. It's very easy to add devices to an existing Modbus TCP network, whereas Modbus RTU, you need to plan the wiring and be aware that you can only have one Modbus RTU master at a time, so only one software package or PLC can communicate to it at one time. If, for instance, you wanted to do both, you need to set up your PLC as both a Modbus RTU master to read from the devices and output it to, say, a SCADA system like InduSoft or AVEVA Edge. So it gets a little more complex, whereas if you had Modbus TCP slaves, you can read the data from the devices directly. So again, I prefer Modbus TCP over RTU. Let's see, this is the Modbus register table. This is the second piece of information you need for the individual devices. This is for the M7026. So again, this one had 2 analog output channels, which are registers 40,033 and 40,034. And then the analog input registers, it has 6 of them labeled channels 0 through 5. And the Modbus addresses associated with those are 30,001 through 30,006. To bring this all together, let me just go back to AVEVA Edge and show you, well, actually, let me show you this first. Within AVEVA Edge or in Indesoft, they have wonderful help documents. Let's see, let me create a new project and let's just call it, I don't know, let's call it demo spaces. So I'll do Modbus typo. Let's see, we're just going to use the standard Windows version. AVEVA Edge can run on both Windows systems and embedded systems, including Windows CE and Windows XP embedded and Windows, pretty much Windows Server editions as well. Okay, we're going to use standard resolution. Let's see, we're going to skip this part because is this okay? That's fine. Oh, I thought I clicked no. I'll just use standard security because I really don't care for the demo purposes. Okay, so when you want to create your graphics, you would simply insert a screen here. Like for instance, I'll call this the main screen. If I wanted to add buttons or a trend curve, I would just simply insert the object here. Like for instance, I'll click trend, draw a curve, and associate my tags down here. But skipping ahead, first of all, I probably want to create the communication so that I can talk to my devices. So I click on the communication tab here, the driver tab here, you right click and do add remove driver. Here is a list of all the built-in drivers Indesoft/AVEVA currently have. You can also create your own, or there's some you can probably add that are not here. There's a few that you have to pay for as well, but for the most part, most of the ones that we are associated with in our field bus and Modbus, the drivers are built in. You can also use the RxTX driver to communicate to our decon modules. So for this example, we're going to use Modbus RTU, which is this one right here. We click, or we double click on it, and it adds it down here. And the help document that I was referring to is right here. You click on the driver and then you click on help. Oh, actually, I'm sorry, I need to go back there. I did that wrong. It's actually, you have to unselect it and you highlight it up here and then you click on help. There we go. That's how you get the Modbus RTU driver. It shows you a very detailed steps of everything you need to do to connect your Modbus RTU device. I'm going to show you some of it straightforward. Just want to show you how detailed it is. For instance, if you have different types of analog values, this shows you how to format the tag value. Let's see, I'm going to close out of this. I want to be sure to speed this up so I can answer some questions as well. So we'll just do a quick example. I'll show you how to add a few tags. So I set up the Modbus driver, or selected it rather. Click OK. And you come over here, go to the main. Actually, first of all, with Modbus RTU, you need to set up the COM settings. So you would right click on Modbus, set the COM. For instance, I had this one on COM 4, I believe. 9600 8N1, that looks good. And then you click on the Modbus driver sheet, you create a tag name, I'll call it analog output 1, and station ID is the Modbus address. Okay, which in this case was 1. That's based on my page right here where it says address 1 right here. And then the tag value based on the Modbus. Go. Modbus register table, which is shown here, is 4x33. So we do 4x:33. So it'd be like that. And this is a read write tag. If I wanted to do an analog input tag, I do AI. Actually, I'm sorry, that should have been 0, but that's okay. We'll just create it now. 1, and this is a 3x, and then :1, based on the Modbus register table, which this slide right here, which is up here, 30,001. Back here. And if we wanted to create a graphic, we can come back here. Actually, I want to save this first. Right click and save. And come over here. Create a new screen, which I thought I did already, but I guess I didn't save it. But do that, then we can, maybe create a trend curve and put those tags in. Let's see, where is it? Points. And data source. Okay, so we want to do AI 0, for instance, is the tag, or just a description. So actually that should be like tank level. And then the tag associated with it, this is where I want. Let's see, and not save it. It would be AI, was it 0, I think? I think that's what I set it for. And we will try it and see if it works. Am I seeing data? I don't know. Currently, I'm seeing 0. I don't see any errors, so I think I'm okay. Right now, my value is probably 0 because I have nothing connected to it. But the other thing I want to show you, let me close this. You should always put in an exit button. That's one thing I always seem to forget. The symbols, I think it was symbols. Project symbols. Okay, this is the library of images that you can use for creating either buttons, bar graphs, and all the different objects you can use in your project. But the one that we like to use is the one right here where it goes. There we are, exit button. Double click there and put it there. This allows you to close the project from this window. Does anyone have any questions on creating connection? Again, the most important thing is making sure that the correct driver is chosen for the project. And again, use the help documents, like for instance, the Modbus one, to determine how to configure the connection and how to create the tags associated with those objects. Then from there, you want to use your animations or drawing widgets to visually show your project. If you want to create a background image, that's also another thing you want to do. You can simply do background color, or you can add a background image by right-clicking. And in this case, you can do background color. I want to change it to like this color. Just change everything, or you can create a picture and just put it in the background as well. And be sure to bring these other objects to the front. Does anyone have any questions on anything either Maria or I showed you today? Let's see, if you have any questions, please type them in the chat box. Or if you want to ask them live, let us know, then we can unmute you. Let's see, I don't see any.
You can always send us an email in case we can help you in the future.
Let's see, I don't see any questions at this point.
Okay, so I'll be sending everyone information on the webinar afterwards, and then within a few days we should have the video up on our website. So I'll also send you that. Thank you so much for attending, and I hope we can help you in the future.
Okay, and we'll see you next month for our next webinar. Take care all.